Let's start with a message up front. Originally, this was going to be like a full, complete introduction to how you start working with Databricks and do a bunch of ETL. Now, Simon Whiteley over there, wave Simon, also has a Databricks session, and it happens to be right after this one. So we talked about it a bit, and what we're going to do is the following. I'm going to go from the absolute beginning of Databricks, so what it is, where the buttons are, what you do, how it works, what you click on, how do you run a query on the thing, how do you attach it to storage, whether you keep the secrets, the passwords, all that kind of stuff to get you started with Databricks. So you know how it works, what to do, etc. Then I think I saw Simon's demos already. He's going to melt your brain in the session afterwards. And yes, sound good? So if you already at work do a lot of work with Databricks and you came more for the higher end Python stuff, you can get yourself a coffee for now and wait for Simon's session. It's totally fine if you walk out. I'm not insulted. Did this last week in Oslo and 3 people got up immediately and walked out. Okay. So, a bit of... I just had to reboot the thing, and if you're ever a speaker and you come to the thing and it won't go to the screen, check if you have pending updates, because that's what Windows does these days. It won't connect to a screen if you have pending updates. You have to restart your machine, wait until the percentages thing is completely done, reboot, then plug it in, and then it works. So if you're here 5 minutes early, I hope, I've seen speakers completely panic and go, why doesn't it work? Just reboot, you'll be fine. Yeah. So what are we going to do? Let's start with, well, you've seen this probably a couple of times before, but since I organize an event myself, I know that buying coffee for 200 of your best friends is not free at all. So you need sponsors, and it's really cool that there's so many of them actually. This is pretty cool. This is a good list. So if you have the chance, chat to them and whatnot. They really appreciate it. Now, this is me also. I'm afraid I'm going to have to disappoint you today. I have no PowerPoint whatsoever. There's nothing. For the PowerPoint fans amongst you, sorry, if you want slides with bullet points and everything, don't have it. Cheating a bit though, they're all in here in this notebook. And what the notebook is and what it does and how it works, we'll get to that. So this is me. I'm Dutch. I keep getting this question, so I might as well answer it right away. I have never in my life been in a coffee shop. I don't know how that works. I cannot help you there. I actually live in the middle of Amsterdam. I smell this stuff a lot, but never been inside a coffee shop. I do know we have a smoking ban in public places. You have that here as well, I think, right? So this is a bit awkward if you have a coffee shop to run. So we have an amendment to the law. Like the Americans with the guns things. But we have an amendment that says you can smoke cannabis in a coffee shop. Not normal cigarettes. That would be illegal. Seriously. Don't know anyone who's checked that though. So if you have any other questions about the Netherlands, I might be able to answer them, but don't know. I feel like such a tourist myself in Amsterdam still. Anything else? If you have questions after this thing, or if you wanna, I'm actually using the Stack Overflow database because everybody recognizes a bit. I've stolen Brent Ozar's copy that he makes and turned it into a Parquet files. Those are, we'll get to that as well. So you can tinker with Databricks with the Stack Overflow database. You can run some queries that you'll understand and work with. I don't have to explain the schema and such. Makes it a bit easier. Anything else about me? Nah. Contact me through Twitter or email or something. If you have questions, let me know. no worries there. So, who is working with Databricks? Few, except for Simon. I'm a bit of a beginner in Databricks, but I got quite the challenge. Let me do the background of why I'm doing this. Maybe that helps understanding why I'm tinkering with this and want to find out how this all works, and why I'm also very interested in the stuff that Simon does. I work, this is being streamed, so I need to be careful what I say. I work for a bank in the Netherlands, and I work for the fraud and compliance department. So what's in my database we cannot discuss, but it's a lot. It's a lot of data. I sometimes have my diva hat on when people talk about big SQL servers. Oh yeah, my SQL server is the biggest on the planet. Oh yeah, what do you call big? Diva hat on, right? Currently I'm the proud DBA of just one SQL server. My job has never been easier. Unfortunately, it's 150 terabytes. For the fans of raw iron and numbers and whatnot, to give you an idea of the size of what runs a 150 terabyte SQL server, here we go, it's an 8-core VM. Did we get that? Yeah, it's an 8-core VM, 700 gigs of memory, that's it, runs fine. Anyone that tells you that SQL Server doesn't scale, send them to me, I'll show them. Works totally fine. If you need an index though, you need 4 days. One of the tables has 60 billion rows. I have users that do a select count star, and I'm like, don't do that. So I'm currently moving that stuff into Azure, and I'm playing with Azure SQL Data Warehouse, which I understand well. And I'm also tinkering with Databricks, which I didn't understand that well, and that's why I dove into this Databricks stuff. Because also, a project manager came to me and said, André, we have some more data that we want to load in that database of yours, but it's a lot. So diva hat on again. What do you call a lot? 750 terabytes of zip files with logging information in it. Okay, diva hat off. I call that a lot as well. So currently there's, you know these boxes that you can get for Azure, that you can get them, put them in your data center, load data on, and then bring them to Azure, and then they unload it if it's too big to go across the line. We have something called a data box heavy in our data center. It has a capacity of 1 petabyte, and my colleagues are currently copying files on it. And I need to read them at some point when they arrive on storage in Azure. This is why I'm tinkering with Databricks, because I think that's a good choice. Before I stick it all in a data warehouse, maybe I could just read them with Databricks a bit. Now, what is Azure Databricks? Let's go back all the way to the beginning. There is something called Databricks. It's a company, and they have a Databricks for Amazon as well. And Azure Databricks is nothing more than the cooperation between Microsoft and Databricks to make Databricks work really well on Azure. So to integrate it with Azure AD, to make it really easy to connect Azure Storage, to make it work from the portal, all these things. That's basically Azure Databricks. It's not something specific to Azure. You can get Databricks on Amazon, you can get it on-prem if you want to. Now, Databricks itself is nothing more, I don't want to sell these people short, but it's basically nothing more than a management layer on top of Spark clusters. Now, who is working with Spark here? Nobody. Not even the people who said they work with Databricks, which is funny. Because what you do is working with Spark. So Spark, do I have something here? No, that's coming, okay, comes next. Spark is something that has been written, it's open source, and it will read basically, it will process data for you. We'll look at it later to see what it does. I'll show you some. And you never have one system with Spark on it. You always have a whole bunch called a Spark cluster. That's what you do. You divide and conquer. You have a bunch of files in this case to read. So attach a Spark cluster to your storage and you attack the files. And the Spark cluster will process the data in memory and give you a result of what you asked for. This was hard to maintain, hard to set up. Maybe it still is, I don't know. I also don't care anymore because now we have Databricks and it makes it super simple to create a Spark cluster. Now, before I talk and talk and talk, let's show you a few things, right? What you're already seeing here is inside Databricks, what you're looking at. This is called a notebook, and you get one, a Databricks cluster, by going into Azure and say, I want new Databricks. And it creates, if I show you here, I have two of them, Databricks instances. And all you need to do here is click on the thing. Mine is called Demo Bricks. And then there's not really many buttons. There is Launch Workspace. If you click on that, it opens this, and you end up here at the top. That's basically what you get. You can't do anything with it yet. It has no compute power. There are no Spark clusters underneath. So you'll have to set up some compute, and then you can give it, and then connect it to storage, and then give it some commands. So why is all this why do you need clusters of Spark, right? Let me show you something, and to give you an idea how that works, let's go to my workspace. Here's my admin notebook. Scroll down. This is just a picture inside a notebook. This is the cool part of notebooks. You can document your own notebooks, but because it understands Markdown, so you can also load images from your Git repository or something. This is how I got the images in the notebook. But it's actually to put your commands in. And I'll show you some commands later. Now, let's load this picture. No, I said load. That would be Shift Enter. And this is what Azure SQL Data Warehouse does as well. And this is from an Azure SQL Data Warehouse perspective, this picture, but a Spark cluster basically does the same thing. In Azure SQL Data Warehouse, you don't have one SQL server, you have a bunch of SQL servers. Your tables are not in one place, they are in 60 different places. If you create a table in Azure SQL Data Warehouse, it actually creates 60 tables for you and divides all the data amongst the 60 tables. And then it gets connected to however many compute nodes you made in Azure SQL Data Warehouse. So if you made 10 of them, every one of them handles 6 tables with your data. Now, something as simple as select count star from big table, it actually involves a lot of work because there is no such thing as one big table. There's 60 of them for all of them. So what it needs to do, there's one head node that needs to say, all right, a control node in Azure SQL Data Warehouse, that needs to say, all right, I've got 60 of them, I've got a bunch of compute nodes, so I'm going to give, if I have 10 compute nodes, for instance, I'm going to give 10 commands to do, 60 commands to the 10 compute nodes to each do select count star on all the tables that they have. So every compute node does 6 of them and gets 6 results, save them, move them up to the control node. It has 60 results, and then it has to sum them, right? So there's a lot of moving parts to get even a simple thing as a select count star. This is Azure Data Warehouse, where the storage is included in the data warehouse, so you have to load the data warehouse. And this is also the big difference between Azure SQL Data Warehouse and Databricks, because a Spark cluster is compute only. There is no storage at all. There's only compute. So you don't have to load it, yay? You can just attach it to where your files are and start processing them. If you have all your data in CSV files, you're already done. You don't have to load them in databases. Probably not the smartest thing to do, have all your data in your company in CSV files, but you could if you wanted to. Now, let's go to the clusters here, and I'll show you what happens here. Because what you have to do is create a cluster. Before you can do any computing, you have to create a cluster. You can, standard it will say, okay, what kind of Python do you want on the cluster nodes? What kind of workload you want to run? So how big do they need to be? As you can see underneath here, they're all Azure VM sizes. So you can pick your own sizes. So if you want, that you can choose there. Do I want 3 nodes with big VMs, or do I want 100 with small VMs? And what is the best choice? It depends. Maybe you can explain it depends way better than I do, but it depends on your workload. Some will run really well on big nodes and you don't need too many of them. Some will run really well on small nodes, and then it's good to have a lot of them. You have to tinker with this and figure it out. There's whole conferences around how to tweak and tune this stuff. Spark has become a big profession, basically. So you can say things like, okay, if I stop using this thing, switch it off. After 2 hours, switch it off, it's fine. You can also say, if I hit it really hard and you see it overloading, add more. Like you can start with 3 of them, like this one, let's see. Min workers 2, max workers 8. So this fires up 2 of them if I start it, so I can do things. But as soon as I start hitting it, it might grow to 8 of them. And this is install, get an Azure VM, install Linux, it's Linux. Install Spark, configure Spark, install Python, the right libraries and everything. It does that for you, don't worry. All you have to do is, I want this many of that type, go, right? That's it. This is the cool part of Databricks, it takes that away. Now, the Databricks people are the major contributors to the Spark open source library. They basically made it for a big part of it, and they're still involved. So they know how this works. Right? If you send a query to a Spark cluster, it gets optimized by Spark. If you send a query to a Spark cluster from Databricks, it gets optimized from Databricks first and then by Spark. So they do some really cool tricks there. Now, once you have a cluster, you can take a notebook. Let's have one here, the one that I was showing you with the pictures in it, and run queries on it. So if I just go to a simple query, like select year or select count, this will do. Control 4. All I have to do. Now, it takes my query, interprets it, sends the command to Spark. Spark figures out how to distribute this and divides the work across the nodes. So maybe you have one big file and then it tells the Spark nodes, okay, everybody read a part of the file and count the results and bring them together and sum these things, like I just showed you with the example query. Or maybe you want to join something. Then it has to figure out how to do that, because now you have to maybe take data, and then if you want to join it, the join has to be correct. So the smaller thing that you're joining to have maybe has to be copied to all the nodes, so you can do a correct join. What it does, it looks at how big your data is. It might get it wrong, and you can give hints. But as we know from SQL Server world, be careful with the hints, right? If you get it wrong, it's like your significant other saying that you should clean out the dishwasher. It's not really a suggestion, right? You may actually need to do that. So, what you see me do here, I just ran a query. And because in my notebook, where it's just a bunch of boxes underneath each other, and you can go through and put your whole process there. I want to do this first, and then make a file, and then read the file, and then load it into a data warehouse. You can talk to other storage. It doesn't have to be blob storage or something. But now I'm running a query. This is called Spark SQL. It's a SQL standard. And because my notebook has the default language of Python, anything that is not Python in these things, I have to tell it what language it is. So that's why there's a %SQL up above that tells this notebook what comes next is a query, basically. So that's why the one above, you just see the command because that's Python, and it doesn't need to know it's Python because that's the default language. That also brings me to something that you want to watch out for. Here, for instance, is a file system command. And there's also a utilities library in Python that lets you do a lot of file system stuff from Python. But I'm now running a file system command. And these commands are usually approximately the same, but they're different languages. You can intermix the languages inside the notebook. So what I ran into, for instance, is I wanted to delete a file, and it had to have a boolean at the end confirming the thing. So I put true, or T. Not sure which one it was. True, I think it was. Failed. I'm like, what's that? Read the documentation. I do it correctly. Turns out, okay, something fell asleep here. Stay awake. Turns out, in Python, the command needs lowercase t, and in the file system thing, the thing needs a uppercase T for the true, for the boolean. And the error message is anything but, all right, listen, I think you got a capital T there and it doesn't need to, that was not the error message. I don't remember what the error message was, but it did not give me any clues. So be aware that you are working with different languages, and the documentation sometimes gives you an example about one language, but it might be the other, and there might be mistakes in that as well. So be aware of those things. Also, if you type in queries, like the query here, I just do my SQL queries, like select top, blah, and there's no such thing as a top, it's a different one. There is columns with spaces in them, I put brackets around them, error message. I put double quotes around them, error message. Single quotes around them, error message. Finally looked at the documentation, now it has to be a backtick around them. Okay, fine. So that it's SQL, but it's kind of different, and don't be stubborn, read the documentation, because the commands that you want to use are slightly different, and it will drive you nuts if you just try your SQL knowledge from SQL Server at it, because it's just not the same. Now, there's also, instead of a result set, you can get a graph. Bar graph will be not very interesting with one result, but you get the idea. So you can use this for visualization and just go through, where am I? Where's the grid? Oh, here, next button. You can go through this for visualization, but what you can also do is make a whole process, like an ETL process or something. File comes in, I tinker with it, I do a query, I save it to another file, do something else, and then I bulk load it into a database or something. And once you're done, or once you've done your research and you're ready, you might say to somebody who administers Databricks, or as we say in the Databricks world, a DBA. I just made that up. Can they steal our terms? DBA is ours, right? SQL Server people. Or are you not SQL Server people? Am I in the wrong room? All right, who is the SQL Server person here? Enough, okay, I feel safe. Oh good. So, what you can do is take this notebook, let me zoom out again, and go all the way to the top, and just schedule the thing. There's a schedule button, and you can just say, hey, I just want to run this thing automatically, the whole notebook, and just run it for me at night. Now, if you tinker with this and you just do it this way, be careful, because you cannot see this on this interface, but what it will do is create a new cluster for you every time you run this. So I did a demo once where I scheduled it once a minute, and these clusters clean up after 2 hours. So after 2 hours, I had a lot of these clusters. This is Azure money that you're burning. It can be quite expensive quickly, so be careful there. You can actually go into the details of the schedules on the Schedules tab here. Jobs. I don't have any right now, but there you can change it. Like, don't run it on a new cluster every time, but use an existing one, and you can point at one. Use this one. This is the cool part as well. You can have as many clusters as you want. Right? I've made one cluster here in clusters. Click on it. Yeah. So I've just got the one, But you can have many. You can have, maybe if you have something that needs to be running all the time because you're running ETL on something that comes by every 5 minutes, have a cluster running all the time that has little resources because maybe it doesn't need that much. If you have heavy-duty processes at night, give it a big one at night and leave the other ones alone, right? You can have many compute clusters. Also the cool part, because this is completely detached from your storage, you can point to the same data. So I have my data here, and I'll show you in a bit, in an ADLS v2, a data lake v2, and I can make multiple clusters that all point to that same data and do things with it. So if somebody else wants to run heavy reports, but I don't want to have my reporting or loading or whatever I'm doing be in the way of the other ones, I'll give him or her their own cluster. It's totally fine. Now, oh yeah. Let's go back to the beginning a little bit because I have to talk to you about that one. As you can see, I have a trial version here, 14 days free. It is not free, right? If you're playing with this, so what they do, they create in your clusters, they create VMs, and when you run them through Databricks, you pay money on top of that, right? That goes the Databricks units, or what are they called, DBUs? Extra money for Databricks, basically. That's how they make money. So you pay for the VM and you pay for the money on top to be able to use it in a Databricks cluster. What you get for free is that Databricks part. You still pay for the Azure VMs. Microsoft is not giving you anything here. So when it says 14 days free, it's that other part. So it's like 40% or something. So if you think, oh, this is free, I'll just run a 100-node cluster. Yeah, you're going to run out of credits really fast if you have those. If it's connected to your credit card, be really careful. We're lucky MVPs get a bit of credit from Microsoft, but we're supposed to do a year with that. I managed to kill mine in August last year, and I got it in July. So tinkering with stuff in Azure is cool, but it's never free. Be careful there. Now, there's a few things that you'd probably want to think about when you get started. This is where it gets a little bit more complex, but I would dive into it as well. I've got half an hour left. Okay, good. You can connect to free storage, like storage that doesn't have a password, not free. Forget about the free. Nothing is free. But that means you have to work with storage that is open to the world, right? That's not cool. Even if you say, well, I could put a data set there that is just for demo purposes, so I don't care if somebody steals the data. True, but they don't have to steal it. They can also attach Databricks clusters to your free data and then start working on your free data in your storage because you've opened it up, and then you'll get a bill for it, right? You want to be a bit careful there. So what you can do is take Azure Data Lake storage instead of blob storage, because Azure Data Lake storage v2 is much faster. It has a lot of advantages over the normal old blob. Is there still an old blob, or did they kill that? It's still there. Still there?
Don't use it because it's fading out of existence.
Yeah, it's like the Data Lake Analytics, right? Is that still there? Yeah, whoever does use that, don't stop doing that. What you do is you take the ADLS v2 and you connect to it through Databricks, but now you have to get a username, password, or something, right? So what you do is in Azure Active Directory, you create something called an application registration. That would be here. I've got a Demobricks app, and that Demobricks app is like, look at it as like a service account inside Azure that will be able to connect to your storage. And you can use the credentials of your service account from Databricks to go to your storage, because your Databricks is not really connected as an Azure account. It is not a storage account itself. It's not a managed account. Simon, do you know if they plan on doing that? Have Databricks just be a managed account that can just go to your storage if you give it rights? Like they do with, you don't know?
No.
All right. So sometimes he does know, but he can't say. So he has to do the same face.
That one I generally don't know.
Oh, or did you practice that one as well?
No comment.
So what you could do here is create a secret. And this secret that you see down here gives you basically a password to be able to use this service account. And you can create a couple of them, so you can create different services can use the same application account but have their own secret, so you don't have to give the password out to everyone. You can also set when it expires. So in about a month it won't work anymore and you have to refresh, which for service accounts maybe not really useful, but there. Now, what you do with that secret, and this is multiple steps here. This secret can go into Databricks, but I'm going to take a little bit of a detour. I'm going to attach Databricks to a key vault and put the secret in the key vault. Architects love that stuff, when all the secrets are managed by the company itself in their own key vault. And Azure Databricks can just use that key vault to have the secrets stored there. So that's what I'm going to do. Now, I'm in the resource group. Where are we? Demo. Here is my key vault. And come on. Secrets. And in my key vault is a secret, a Databricks app, and here's only one version, and here is the secret value. I can click on show secret value, but it's just to generate a password that will be destroyed anyway. So, all good, right? So now I have to attach Databricks to the key vault. Now, as you've seen in Databricks, there's a bunch of buttons here. For instance, for the jobs, here's the clusters. We'll get to the data part later. Here's the workspace that has the notebooks. And there's a home thing. Where's the secrets thing, right? So there's a few funny ones there. There's a few hidden user interfaces in Databricks. There's no button for it. I have no idea why. Simon, do you know why? It's weird. This one, like I go to home, like Azure Databricks, I click on the URL, and then I go secrets, create scope, and out pops a user interface that's not reachable by a button. Why?
Yeah. Make it as hard as possible to secure things, right?
Yes. Obfuscation. Architects that are in charge of security do not like that one. Anyway, this is where this screen, and you need to have this URL or else you won't find it. Just go to home, attach this, create secret scope to it. And then this is how you attach it to the key vault. You have to type in some numbers that you can find on the key vault. You just copy, paste them, and it will attach your Databricks to your key vault. And from then on, inside Databricks in Python, you could just grab the password and connect to storage. I'll show you that in a bit. Now, there's one other weird thing. There is also no screen, as far as I know, to show the secret scopes that you've created, because this allows you to create a secret scope for a key vault, but you can have multiple key vaults. You can have other types of security places, as long as you give it a unique scope name. And I typed one in, and then I thought I typed it in wrong, and I thought, where's the list? And I couldn't find it. Turns out there is a way with a command line to install a Databricks command line thingy that will allow you to query the scopes, but the username and password of that command line thingy are in a file on your drive, unencrypted. So that scared me a bit. So if you read about that one, don't be careful there, because somewhere on my file system now is a file that has a username and password to do whatever I want on Databricks. Not sure what's that about. So once we've connected it, and I'll go to the admin thing, we can mount drives or storage. Here is example. So the first one, dbutils.secrets.get, and then I give it the scope, so the name of the key vault connection I made, which I call DemoBricks key vault scope, and the name of the secret that I want. So that was the DemoBricks app, and it will give me back the password. It says redacted because Databricks itself is smart enough to not just throw passwords out there, so it just won't show me the secrets, but it has it, right? It can query it. Then I have some piece of code underneath here, and this stuff is fairly well documented. You can get it from the from blogs and key vault documentation, and I'll also share this little notebook. But this allows you to connect to mount Azure ADLS v2 storage to Databricks, and the only thing that is not hard coded in here is the key secret, because you can see on the 4th line that it goes to the secrets and gets the thing. So you don't have to put it hard-coded in your notebook, which would not be smart, right? So this thing, you do it once from an admin perspective. You take the drive that you want to connect, and you get the key from the key vault, and you mount the drive. And this one is mounted as mount point, mount Stack Overflow, as you can see there. Now, all you need to do to make that work is in storage account that you have. Here's my DemoBricks storage, Data Lake Gen 2. Here's my Stack Overflow file system. But if I go to access control and look at role assignments, you will see that it actually has the DemoBricks app as a storage blob data contributor. That's what it needs, amongst, there's others. But this gives me a lot of freedom with this storage. I can also write to it. I did the wrong ones. It's really easy to not pick the storage blob contributor, but the other contributor, and then you're going crazy because all the mounting works, but then the querying doesn't work. And you go, why does it mounts, so why doesn't it work? But I gave it the wrong rights, and the error message is not helpful. So now I can connect from Databricks to my storage. So if I do ls, Linux speak for show me what's on the file system, it shows me that I have a bunch of files. These are the Stack Overflow Parquet files. Why is there a lot of queues in the thing below me? Did I clearly typed a bunch of stuff here. Let's remove that. Interesting. So I have a bunch of files here. Now, Parquet files. This will work with CSV files. You can actually tell Spark or Databricks to read CSV files as long as it knows the structure, and you can even say, figure out the structure. I don't know what the structure is. You figure it out. It might have a header. Look at it. That works. Doing it every time, not the smartest thing to do, right? It makes it slower because it has to read part of the file. So you can also store the structure of these files in a data storage. And Simon is going to show you a lot more about that, so I'll keep it short. But here, I've done that. I've made tables. I have to do this. Not like the Joey from Friends, like I'm sorry. But anyone seen Friends? No? No, so Databricks now knows the structure of my data. That's because I've told it to store that. Right here, you see the commands. Don't try to memorize these things, but what I'm saying is you create a data frame and you say Spark read the format is Parquet, load this file, and then save it as a table. Now, this is not the smartest thing to do it this way because it's going to read the whole file to figure out the format, so it might take a while. But it works, and Simon maybe has smarter ways to do that later in the demo, I don't know. Maybe I'm piling up to your 1 hour of time that you have, but you can create something called a struct and just give it the command. Here, this is the create table basically. Do it this way. Opening up his laptop there, creating a demo now. Good teamwork. So basically now I have the structure, I have the connection to the storage, it's all secured, it's all fine, everybody's happy. And now I can go and read from it. And this is how, I got this fast here, but I can also use this one. I was able to run this query, Control 4, it's better. Now, oh yeah, Parquet files. In Azure SQL Data Warehouse and in SQL Server, there is an index format called column store. Do you know what column store is? Right? Without going into depths of what it is and how it works, it's a different way of storing data, right? It compresses your data significantly, also stores it per column. So if you query it and you want column A and column B and you don't want the rest, it doesn't have to get it from disk and it doesn't have to load it in the CPU and in all the storage. It doesn't need to touch it, so it can skip all the other columns. That's highly optimized storage format. Also, it's in blocks, and the blocks in a column store in SQL Server will have a min and a max of everything, and it will have a dictionary of what is in this block. So if you're looking for data from 2019, it will know what not to touch on disk. Right? I need these columns, so I'm going to just read this, and I'm going to skip all these things that have 2018, 17, doesn't matter, without needing indexes. That's basically what it can do. Now, Parquet format is similar, very similar. It keeps evolving. I think the newer Parquet format can also do the statistics in the blocks. It's not as sophisticated, I think, as a column store in SQL Server, but the format is similar. So it is a column store compressed based format. It has structure also. You don't have to tell any, you don't have to tell it what columns there are, if it's comma separated or not, it doesn't matter because it knows. Funny part of Parquet files is, and that's a trick I haven't seen in column store in SQL Server yet, you can also have substructures inside a Parquet file. So if you have a JSON file one of the columns would be JSON, you can do that and you can dive down into the rabbit hole in there. That's an interesting one if you have a bit of unstructured data there. Now, it's highly compressed. You can clearly notice the difference. If you're querying CSV files and then turn that into a Parquet file, which in Python is just one command, just read this CSV file, write to disk, make it Parquet, done. It's really easy. Also, Data Factory can create Parquet files. It's very simple. It will be faster. So if you have the choice of formats, turn it into Parquet, I think. There's a few others, but I think Parquet is the most common one, right? Get a thumbs up there. Now, where are we? 15 minutes left. So come on. Oh, Control 4. That's where I am. There's also a few things that you have to keep in mind. Like, for instance, I have a query here that's quite a complex one if you don't have the right indexes on them, right? This is where I think if you have structured data and you have the time to properly load it into things like an Azure SQL Data Warehouse and index them properly, you have the time to do this in your process, you'll always beat a system like a Spark cluster, because there's no indexes. You're always reading almost everything. The new Parquet structures may make it so it can skip certain things, but there's no such thing as an index in Spark because it's file-based. Also, Spark is compute only. It doesn't control the storage. So if you add something to the storage, it doesn't know. So it can't make sure that there's an index that's complete and whatnot. It doesn't have control about that, so it doesn't do that. There is something that you'll hear more about more and more because Databricks seems to push it a lot, and I have not played with it, but I'm sure Simon has. Something called Databricks Delta, and it will allow you to load files onto existing storage while you're querying it, and it will have some kind of a transaction log file even, and it will be transactionally consistent somehow, and that they are tinkering with the indexes possibility right there. I don't think that's quite baked in yet very well, but Something you'll hear about is Databricks Delta. Might be interesting to look at. So you can take this Databricks, what I've just connected to storage, you can connect it to Azure SQL Data Warehouse. You can have streaming data coming in through Kafka and just attach it to your Databricks cluster and collect all the data that comes in on the streams and do something with it. You can roll out clusters, Spark clusters with graphical cards in them and machine learning libraries on them and do machine learning right on the nodes and preload the libraries and everything. There's a lot of things that you can do that go way beyond what the hour that we have here and also way beyond what I understand of these things. So it is really powerful. There are, like I said in the beginning, conferences around optimizing Spark queries and whatnot. There's how to set the memory and whatnot. You can get a lot of data out here. If I run some query, how long does this take? Here's a somewhat complicated query. What did I do? Oh, here, I'm running it. You can see I'm running this here and it has a bunch of steps so you can follow actually what it does. You can get a lot of information out, even the distributed query plans. So if you have to dive into this a bit to figure out what it does, because distributed query plans are quite different from the query plans from SQL Server. You'll read things like broadcast, hash join, and hash aggregate and whatnot. Those are commands to the Spark cluster to say, okay, here's some data that I want you to broadcast along all the cluster nodes because you need it everywhere. If you want to join something, for instance. You can get the query plan by just typing explain above the query and it gives you the query plan. You can put hints in there to force it to copy a certain, if you have a dimension table and you want to, and it's big, and Spark decides to shuffle the thing and you want it copied, you can do that and use bigger nodes. There's a lot of stuff you can do there. I wouldn't start there though. There's a few languages that it has been written in. So the first language that I'd like to mention is Scala. That's the language that Spark is written in. And then there's R and Python and Java and SQL. Now, if you are unfamiliar with all these languages, I suggest you start with Python. That's probably the most accessible one. That's probably Python and SQL, probably the only ones that you'll need, except for the occasional line of code that you're going to have to run in Scala because the other libraries don't support it yet. Yeah? Right. That's my experience. That's what I ran into. I've got like one line of Scala that I needed to copy paste from a blog somewhere. That's about all my Scala that I did, and the rest is all Python. And Python, since it's a Dutch language, I'm all good with that. If anyone would have told me, so I've been in IT now for 30 years. Oh my God. 30 years. Damn, gray hair, that's where it comes from probably. 30 years in IT. If somebody told me 20 years ago, Python will be the language that everybody uses in 20 years, I'm like, seriously? Come on. But yeah, I have a colleague, she is 26, 27, somewhere there. And she does everything in Python, does machine learning libraries. She has machine learning to figure out if your data has changed enough significantly to tell the machine learning people to change their models and to retrain them because the data has changed, and she has a machine learning model to see that. And every time she tried to explain that to me, my brain started melting and I needed more coffee. And I'm like, let's start with reading some files in Python first and then I'll come back to you. So I think we just got a few minutes left. Without going into way more details that Simon is going to do, so I'm going to stop here and give you some time to get out of this warm room, get some coffee, and then come back here because Simon has he's going to dive deeper into this. There's going to be more Python, more metadata, more, yes, already rubbing his hands. So if you want to see some more of what this thing can really do, then come back here in 20 minutes, somewhere like that. Now, one thing that I still need to show is, of course, in admin, go all the way down. Here we go. Very important. There is session feedback and event feedback. I don't know how they do it, what they collect, but if you can give numbers, this is for us, it's totally not a competition of who is better, but if you have the opportunity to put a text and you think, I was not so impressed with this part of your presentation, please tell me why, right? If you just give me a lower number, I'm like, okay, but why? I cannot learn if you don't do that. Same goes for the event. If you have things that you thought the event was great, but here's what I would change. Please put that in writing, and they really look at this stuff. Every year they try to learn from the feedback of last year. I'm very sure they do that. So please do that. That would be really cool if you do that for me. With that, I'm going to let you go. It's a warm room, so I'm going to let you get some fresh air. If you have any questions, just come up. And only 2 more sessions today. 1 more session today, which will be Simon's, of course. And for the rest, I wish you a great rest of the day. Thank you.